In 1934, Charles Richter developed a scale to measure and compare the magnitude of earthquakes. To come up with the data measured on the scale, we must first understand how magnitude is measured. Seismic waves are vibrations from earthquakes that pass through the earth and are recorded by seismograms. The magnitude of earthquakes can be determined from the data measured at seismogram stations. Seismologists are able to come up with the numbers by taking the log of the amplitude of the waves measured by the seismograms. For example, two earthquakes with magnitudes 9.0 and 9.2 may seem relatively close in magnitude to each other, but in fact the larger earthquake is 10 to the 0.2 or about 1.5 times greater in strength than the smaller one. A seismologist from the USGS is in charge of investigating a recent trend in California earthquakes. A report on this trend has not been gathered in a few weeks, and a fair number of earthquakes have happened since then. In order to analyze the trend in earthquakes, she will review the last 20 earthquakes that occurred in the last 3 days to determine whether the magnitude of California earthquakes is increasing or decreasing. She will compare all the magnitudes she acquires to the baseline comparison of 1.2, the magnitude of the last earthquake she measured. After analyzing all the data, she came up with the equation y equals 1.34563 plus 7.8859 ln x. This shows a positive trend in the magnitude of California earthquakes, as all the constants and coefficients are positive. The screen shows how to find the number of orders of increase in magnitude between different values in the Richter scale. You take the measured value that you measured from the latest earthquake, given to the power of 10 on the top of the fraction, and then the original value that is the standard of comparison as a power of 10 on the bottom of the fraction. Then you divide these values. So this value shows how much the magnitude increases between the original and the current earthquakes. The following is a data table that the USGS scientists acquired, showing the Richter values and the times more powerful values on the right-hand column using the previous formula that I showed. It is clear that there is a positive trend as all the times more powerful values are getting larger and larger. Here is a graph of the original logarithmic equation she provided, which again shows a positive trend in the magnitude of California's earthquakes. We know this by default as the y values of natural logarithms can never be negative. This checks out as the x value shows Richter values and the y value shows times more powerful, and the times more powerful values can never be negative. In conclusion, from the equation the seismologist originally showed, the data table of her past and current recordings of seismic activity, and the graph of the equation, it is clear there is a positive trend in the magnitude of earthquakes, which could be potentially dangerous in the future as each order of magnitude is 10 times as powerful.